Hello there, and welcome to more Math with Mr. Oldenburg. Over here I have my little friend called a printer that decided to start printing as soon as I hit the record button. Hello, printer. Why don't you introduce yourself? It's a Lexmark something or other. Don't have a model number. Anyway, I don't like them. I should be quiet and I can't turn them off because other people need to use them. Anyway, hi. Welcome to More Math. Guess what? Today, we're going to convert metric units of measure. You know what's awesome about this? It's a million times easier than customary. You know why? Because, well, the rest of the world decided, hey, let's use one standard unit of measure to measure everything. And let's make it base 10. So all you ever have to do is move around some nice place values. There's no memorizing tons and tons of different numbers. No. No, instead we have things that have a prefix that all gives a measure, followed by the base word, which kind of just tells you what kind of thing you're measuring. Now, you're probably saying, Mr. Oldenburg, I know you're just talking a bunch of words here, and I don't know what you're talking about because, you're not showing me anything of what you mean. And I know that, but I just always need to get this off the chest because it's just so much smarter than what we do. It really is. Just get with the metric system. I mean, it's what we do in science, right? Right. All right, there's my minute and a half rant. So, first thing you need to know, here's everything. All right. Again, we have length, capacity, but weight changes the mass. And here's a little science lesson for you. Weight measures your pull to the center of the earth, your gravitational pull. Mass measures the amount of something within an object. So it's like, kind of like your density, basically. No, it's not your density because density is completely different. You use density to find mass, so yeah, it doesn't work. But it does measure the makeup of what is in something. Like you have a mass, and it's made up of your molecules that you're made up of out of. All right, so science aside, let's get to math. If you notice, a lot of these values look the same. Why? Because they are. It's simple. Here's those prefixes I was talking about. So each of these three types of measurements have a standard measure. In length, your meter is the standard unit. In capacity, your liter is the standard unit. And in mass, the gram is the standard unit. And from that, we can move up and down based on what its worth is. So you're going to see that the first prefix is kilo. All right, and you've heard this probably on the news a couple times when they're talking about some bad people moving some bad stuff. So the kilo is 1,000 of the general unit. So if your general unit of length is meters, in 1 kilometer, I know it doesn't sound like kilo, it's kilometer, you're going to have 1,000 meters. Same thing over here. If you have a liter, well, we don't really measure kiloliters, but if you did, it would be 1,000 of the liters. And same thing here. If you have a gram, but you wanted kilograms, there would be 1,000 grams in it. Isn't that much nicer than, well, there's 8 fluid ounces in a cup, and then over here with weight, there's 2,000 pounds in a ton, and over here in length, there's 36 inches in a yard. Everything's got to be different. It's so stupid. So much to memorize. Crazy. All right, so going lower, we have things called centi, and centi is good for 100. Think of like a century. Even when they did Roman numerals, the Roman numeral for 100 is C, because it's century, C, centi, things like that. So it means 100 of something. So if I start with a meter, there should be 100 centimeters in it. We don't have centiliters. I mean, technically there are, but we don't use them. And then we don't have centigrams either. However, we do have milli, and milli is 1,000. Good old Aunt Millie is 1,000 years old. Just kidding, she's not. She wouldn't have been around for a long time, like medieval times and stuff. Maybe even before that. Probably before that. Definitely before that. All right, so milli. If I look against a meter, there would be 1,000 millimeters in 1 meter. There are 1,000 milliliters in a liter. There are 1,000 milligrams in a gram. And you're going to remember milligrams because that's pretty much how your medicine is dispersed. If you take pills and stuff, usually it's measured in milligrams. If you're at home taking like your Benadryl, or if you have a sore throat and you take the honey or Dimetapp, I don't even know, whatever you take, you got a fever, some ibuprofen, you generally might take a liquid, it's poured in a cup, and it's done in milliliters. So, that being said, isn't it nice that they all kind of go around the same and have the similar values, and the only thing you're changing is whether you're doing length, capacity, or mass? Yeah, it is. It's totally sweet because it's a lot less work. I know. Now, before we leave this page, one other thing that I want to remind you of. We said that there were 100 centimeters in a meter, but 1,000 millimeters in a meter. Well, if you were to take 100 and multiply it by 10, you would get 1,000. That's why there's 10 millimeters in a centimeter, because even though this is broken down, it breaks down further. So, here's the deal. This runs just like yesterday. The first step, if you have some math to do, you do the function, like in this problem. This says 10 to the third. We need to figure out what 10 to the third is before we could start. Step 2, look at your units. Am I going from small to large to small? That'll tell you your operation. Third, look at your reference chart, figure out the conversion factor, do it. Then compare. So, in number 3, we have 10 to the third. You need to remember your exponents. 10 to the third is not 10 times 3 equals 30. It's the base number 10 times itself 3 times. That's a good review of exponents. We need to know that. Base number exponent. 10 times 10 is 100, times 10 is 1,000. So what I really have here is 1,000 centimeters, and I need to know how many meters that equals. Well, if I go back to my conversion chart, I take a look, I see that I'm going from, oh man, I forgot now, centimeters to meters? I think centimeters to meters. This is going to be terrible today, isn't it? Yup. All right, so there are 100 centimeters in a meter. So my conversion factor is 100. Let me go over here, and I know I'm going to do something with 100. So centimeters, if I can fit 100 centimeters into a meter, I know that this is a smaller unit. If I'm going from a smaller unit to a larger unit, I should get smaller. That means I'm going to divide. I had 1,000 centimeters. I'm going to divide it by the 100 centimeters in a meter. Well, the nice thing about all this is it's all based on place value. So, I see that there are 2 blank or 0 valued place values, and that's in the 1s and the 10s. So I can get rid of the 1s and the 10s here because there is no value. It's 0, it's nothing. This is now 10 divided by 1, which is 10 meters. Fast, simple, not many mistakes. So the next one, we see that we have 58 meters equals how many millimeters? And really what I should do is just write the chart here at the bottom, so that way you could see it. It would make sense, and I don't have to go from page to page. So we have 1 kilometer equals 1,000 meters. 1 meter equals 100 centimeters. 1 meter equals 1,000 millimeters. And 1 centimeter equals 10 millimeters. All right, so here I have 58 meters equals how many millimeters? Well, the first thing is, do I have anything to do here? No, I just have a number already, so that's good. Now, meters and millimeters. I could see clearly that I have more millimeters than meters. This is the smaller unit. So I'm going from a large, large to small, meaning I'm going to multiply. I have 58. I'm going to multiply it by the conversion factor. The conversion factor is 1 meter equals 1,000 millimeters, so I will multiply it by 1,000. All right, well, it appears that I have 1, 2, 3 place values, right? 58 times 1,000 is 58,000. You just tack on 3 zeros. You annex them, you don't really tax it on. And then that is millimeters. Oh my God, I love this. It's so easy. I know. Once you get the patterning, it's simple. They make numbers easy with the metric system. Why it's so much better, because you really can't screw up if you know your place value. All right, we have 1,000 millimeters is how many centimeters? Nothing to do with that number. It's already done. Millimeters to centimeters. I can clearly see that millimeters are smaller, so I'm going small to large. Divide 1,000 by what factor? Well, it's 10. Divided by 10. Boom. 1 0 here. 1 0 here. 100 divided by 1 is 100 centimeters. That is not an M. That is an ugly M. It's getting worse. It's starting to look like a spider with a million legs. Now it's a centipede. That's really weird. All right. Actually, what's really weird, Mr. Oldenburg, is you making that really weird voice. All right. Do I want to do that one? Nah. All right. I want to talk to you about comparing. So let's take a look here at number 7. Number 7 says 9,000 meters is either greater than, less than, or equal to 20 kilometers. I can't compare them because I have two different measures. So I need to make one the other. If I go from meters to kilometers, I would have to divide because I'd have to go to a bigger unit, or here I'd have to multiply. I love multiplying because I can just worry about annexing zeros at the end. So I'm going to take 20 kilometers and I'm going to make it into meters. I know I have to multiply because I'm going from a large to a small. The question is, what do I multiply by? Well, it's a good question. 1 kilometer equals 1,000 meters, or 1,000 whatever this is. So I multiply it by 1,000. That's 3 zeros. 1 times 20 is 20. Then I write my 3 zeros because a lot of kids will only write 3 zeros in all and leave off 1. You remember, you're starting with a 20 there. And that's meters. So 20, let me write this a little neater over here. 20 kilometers is really 20,000 meters. Now I can compare them. I know that 9,000 is definitely less than 20,000. So let me make it said. 9,000 is less than 20,000. One other thing before I leave this page, I want to talk about decimals. I think it's important. So, even though it's not on this page, let's talk about them for a minute. Let's say that I have 2 5/10 centimeters, and I want to make that into millimeters. Again, I don't have to do anything with this number right away because it's already a regular number. There's no multiplication to be done first, nothing. I'm going from a large unit to a small unit, so if I'm going large to small, I multiply. What am I multiplying? Well, I have 2.5. What do I multiply by? My conversion factor is 10. Well, geez. All right, I have 10. How many place values will I move? I have 1 0, because I'm multiplying by 10. That'll move my place values 1. Remember, a decimal truly doesn't move. Place values move around a decimal. That being said, we totally just shift around the decimal. Here we go. My decimal's here. If I multiply, my number should get greater, meaning I would shift one place to the right. And here I'm shifting a decimal. Sorry. Realistically, I should take this 5 and shift it to the left, but I don't want to confuse you. So we're going to shift to the right to make this greater. The decimal will go here now. You have 25 millimeters. Similarly, let's say that I was going from 2.5 let's have fun. Millimeters to a meter. Well, again, I have 2.5. But now I'm going from a small to a large, so I'll divide. And there are 1,000 millimeters in a meter. That gives me 3 zeros, 3 place values. To shrink it, I need to go to the left. That'll make my original number smaller. So what am I going to do? Well, I'm going to go 1, 2, 3. You need to draw the stupid bumps. What does that tell me? Well, I need to fill in 2 other place values, and my decimal would go here. So my answer is 25/10,000ths. Place value is the most important part of all of this. If you forget to put zeros as placeholders in them, there's no way you'll get them right. And that's why I included this on it. All right, let's take a look at capacity really quickly. Again, there is 1 liter, so there is 1,000 milliliters. I'm only going to do a couple of these because I think you're really going to get it. I'll start with number 3 because it has a decimal. It says 2 75/100 liters equals how many milliliters? I'm going from a large to a small, meaning I will multiply. I have 2 75/100 times, well, there's 1,000. 3 place values. 1, 2, 3. I'm going to need to annex a 0. So I'm going to get 2,750 milliliters. So the big thing with this is, and this is what's beautiful about this system, all you have to do is learn the process. Once you know the process and what to do, it's the same thing over and over, no matter if you're doing weight, if you're doing mass, capacity, or length. None of that matters because it's always the same thing. And we're just used to it with milli, and liter, gram, and kilo. So, I should have put the equal sign over there, stupid. Sometimes I make mistakes, kids. It's good to make mistakes. It's what we learn from. So here I'm going from a small unit to a large unit, meaning I'm going to divide. I have 250 milliliters. I'm going to divide by 1,000 because there's 1,000 milliliters in a liter. That gives me 1, 2, 3 place values, so I'm going to have to shift. Now, you might say, Mr. Oldenburg, where's the decimal in 250? Well, kids, it's right here after the ones because it's always after the ones. Even when it's not there, it's really there. When I divide, I'm going to shift to the left because I need to make my number smaller. So, 1, 2, 3 places. My new decimal goes here. I make sure I rewrite it. 250 thousandths liters.
That's like a quarter liter. No, it's not like a quarter liter. It is a quarter liter.
All right, last one. Here we go. We are going to work on mass really quickly. 1 kilogram equals 1,000 grams, just like all the others. 1 gram equals 1,000 milligrams, and that's all we're going to worry about here. So, beautiful decimal right off the bat. 9 25/100ths of a gram equals how many milligrams? Well, I'm going from a large to a small, meaning I'm going to multiply. I have 9 25/100ths. Now, there are 1,000 milligrams in a gram, so multiply this by 1,000. 3 place values, 3 shifts to the right because I'm getting larger. 1, 2, annex a 0. 9,250 milligrams. That's all there is to it. All there is to it. Here I'd be going from a small to a large, meaning I'd divide. I'd divide by 1,000 because that's my jam. Actually, it's just what they tell you. It's not my jam at all. Literally said it right here. Now, this one, let's take a quick look at it. Should try to do a quick erase. I know, no music today for my erasing. Lucky you. So I have 190. I need to make it smaller, or at least decrease its value. Where's my decimal? Decimal's always after the ones. Doesn't matter what number it is, it's always after the ones. I have to divide it by 3 place values. So to the left, 1, 2, 3. 190 thousandths of a kilogram. All right, so even if there was no decimal to start, you might end up with a decimal regardless. All right, finally, let's do some easy comparing, and we're done. Love this question because it doesn't get much easier. 7,000 and 7,000. The only thing we're comparing here is grams to milligrams. Which one's bigger? Grams. Yeah. Awesome. I know. So awesome. You're so awesome. It's like Maui. All right. So last one. Love this last one. This last one's pretty cool. First of all, they give me exponents. Love exponents. Second, they give me two different units. So, step one, get rid of the exponents. 10 to the second power is 100 kilograms. 10 to the fourth power is 10,000 grams. I already know it's equal. No, it's not. Maybe. Guess we'll have to find out. We'll see. So, I can't keep both of these units different. Let's make kilograms grams, because all I have to do is multiply. I have 100. I need to multiply that by 1,000, because there's 1,000 grams in a kilogram. How'd you know? It says it right here. How many zeros do I have? 1, 2, 3, 4, 5 placeholders. 1, 2, 3, 4, 5 placeholders. And a 1. It's 100,000 grams. Which means 100 kilograms is greater than 10,000 grams. Make sure you show all your work. You never know what's going to happen. Always count. Double check. Make sure that what's right is right. You're never smarter than the work. The work must always be done to prove that you're right. Please. Thank you. Good night.